Okay, so today we'll be covering the shortest distance between a line and a point. Just like the name suggests, it's literally the distance between the point and the line, the shortest one obviously being the perpendicular segment that cuts the line, right? Because being perpendicular to a line always means that it's like the shortest distance. Okay, and applications include engineering, construction, and Uber, or like Lyft. Steps to finding this is, first of all, you have to get an equation of the line that's perpendicular to this line. So for example, if you're finding the equation of this line, right? If you're finding the distance between PA, you first have to actually get the red line first, right? Get the red line first by obviously finding the perpendicular line that passes through P, perpendicular to this line, right? So you do that by, first of all, negatively reciprocating the slope. If the slope of the blue line is like 1/2, then the slope of the green line has to be -2. You flip it, and then you multiply by -1. Okay, and then you plug everything into y equals mx plus b, and then your x and y's obviously is the coordinates of p, and then you rearrange for b to get the equation of the green line, and then step number 2 is you set these two lines equal to each other to find your point of intersection. After you find a point of intersection, then obviously you will find the distance between A and P. That will be your shortest distance between a point and a line. Okay. So some things to be cautious of is obviously when you have something like this is not the equation of the line. It is, but you have to change it back to y equals mx plus b form, right? So basically isolate for y, because that's when you actually get the slope. You don't get the slope from this format. You only get the slope from y equals mx plus b format, right? This is all grade 9 review. And again, distance formula, you have to know that to find the distance of 2 points. Okay, so let's do an example together. Find the shortest distance from P to 5 to the line y equals 1/5x plus 3/5. So here, we're going to start off with finding the perpendicular line to the original line that passes through point P. Okay, so here, we're basically finding this line there. Okay, so let's do it. First of all, we have to know that the original slope is 1/5, which means the perpendicular slope is going to be -5. Then we are going to plug it to y equals mx plus b using point P. So that's going to be 5, or x is going to be 2 and y is 5. Mx plus b, 5 equals to -10 plus b, 15 equals b. Therefore, your perpendicular line is going to be -5x plus 15. Okay. Then now, using linear substitution, if you guys go back to your grade 9 lessons, or if you're indeed streamed and you've recently learned linear systems, then you can use linear systems to solve the point of intersection between these two lines, right? This one and y equals 1/5x plus 3/5, I'm pretty sure. Yeah, okay, so to solve this, we're going to use substitution. We're just going to set them equal to each other. Okay, we're going to move 15 minus 3/5 here, and then 1/5x plus 5x. Okay, you can just use your calculator for this part. 72/5 here. be 26 over 5 over here, divided. So you get 36 over 13. That's your x. Your y, you plug your x, this x, back to this equation with this one. So you just plug it back in. 36 over 13. That will give you 15 over 13 as your set of coordinates for the point of intersection. Okay. Yeah. So we found this point. Now we just need to find the distance between this and P to get your shortest distance between a point and a line. So last step. Square root of 15 over 13 minus 5, right? P 5 squared, and 36 over 13 minus 2 squared. Plug that straight into your calculator. If you're an IB student, like, this is grade 10. It's a key to use a calculator, but next year you're gonna have to do this by your hand. Okay, so that gives you this number, which is around 3.9 units. Okay, let's try one more question. A line has a y-intercept of 8 and an x-intercept of negative 12. So that means we have 2 points. 0, 8 and negative 12, 0. What is the shortest distance from the origin to this line? So the origin is going to be 0, 0, right? So you have to first find the equation of this line, and then you find the shortest distance from P to the line made by these 2 points. Okay. That's just information summarized. So first step is to actually find the equation of this line. You find the slope first, right? This is all grade 9 revision. All grade 9 revision. 2 or 3. Then you plug into y equals mx to b. Right. So a equals b. So your equation is going to be that. Just double check if it's correct. Okay. Next, you're just going to find the shortest distance from P to this line. Alright, so let's find the perpendicular slope. Negative 3 over 2. And then you're going to plug your point P, into y equals mx plus b. Your y is going to be 0. These are your 2 lines. Now you need to find the point of intersection. Again, set them equal to each other. Okay, just move the variables to one side. Divide by 13 over 6, you get this number. Plug this x back into your equation here. So 2 over 3, negative 48 over 13, plus 8, should give you this number. Okay, that's your point. You now just need to find the distance between this point and the original point of 0, 0. Okay, But before that, let me just double check my answer to see if it's correct. Your double check this as a point of intersection. Like with these multi-step questions as such, it is important to just check your answer midway, okay? Now for part D, let's just find distance between 0, 0 and that point. So it's going to be 72 over 13 minus 0 squared, and just, you don't have to do minus 0, it's the same thing, so squared. Okay, distance is going to be straight to calculator again. Alright, 24 over 13 over 13, which is going to be around 6.67. No, 6.666 units. What does it say? Nearest tenth, so one decimal, so 6.6. No, 7 units. Okay, yeah, so I hope you guys enjoyed this lesson, and yeah, please give us a comment on our website or just simply subscribe.